Whoa.
Hey Tiny, nice ride. How fast does it go?
It's a chair.
What kind of a payload does it have?
That's a chair, Daddy.
What kind of autonomy does it have?
That's a chair.
Well, that won't work. Let's give you an upgrade. I have no idea where my parents got this chair. It's a tiny little recliner that's perfect size for the kids. I do a lot of work with a company in Ottawa called Robotics. I reached out, didn't really give them too many details, but said I need an outdoor small robot. So they've loaned me a Scout Mini, which is made by Agile X. This robot has 4 motors, 1 for each wheel, so it actually has a lot of torque. And you could swap out the rubber wheels for Omni wheels, and it could actually drive sideways as well. I'm pretty sure I'm gonna be over payload for this, but if this robot is built anything like Frank, it can probably handle it. The mechanical upgrades to this project are all done and they're super fun to drive, but we need some sort of autonomy on this. A project I had done in the summer was take a lazy boy chair and put it on Frank the tank. I used GPS and some cameras to do obstacle avoidance and autonomy. And that was awesome, but I don't have that much extra hardware laying around so I could do the same to this. So we're gonna use some really simple autonomy called a follower package. We're gonna 3D print a marker that we can put on one of the robots, and we're gonna use a camera on the other one to follow that around at a constant distance. This is a really easy way to add all of the advanced autonomy from one robot to multiple robots that just follow it around. I should use all the advanced autonomy on Frank and have the little robot just follow Frank around, but there's gonna be kids on this, and I need to be super careful. They are currently my favorite children. So I'm actually gonna switch it. I'm gonna put the follower package on Frank, and then I'm just gonna manually drive this thing around just to make sure that the kids are safe. The hardware for this is pretty minimal. The first thing we're using is a Z2i from Stereolabs. This is a stereo camera that will get a video stream, but it will also measure the depth to everything around it. The next thing we're using to actually do all the computation and running is a Jetson Orin from NVIDIA. This is an edge AI computer that's meant for robotics. Also, to power all of it, we're just using our 12 volt DC power supply from Meanwell that we're running straight off of the robot. To make the AI for this, we're just gonna be training basic object recognition. So first, we just need a whole bunch of pictures, and we go through and actually highlight the object we're trying to find in each image. I'm using Roboflow for this because it's online and super easy to use. It also has a bunch of augmentations in there. So you can take a certain number of pictures and it automatically creates new different pictures, giving you more training data. Selecting the objects in all these images takes forever and is so tedious. So what we're gonna do instead is actually create new images out of nothing. We're gonna be using Omniverse Replicator from NVIDIA. Omniverse is a simulator that uses really accurate physics and rendering, so you can create photorealistic simulations all inside your computer. We're taking our tracker object that we've created, and we're taking a bunch of pictures of it in different locations inside randomly generated worlds. The best part of this is that the images that come out of Omniverse already have our tracker marked inside of the image, so we don't have to do any sort of manual editing here. We can generate thousands of images to be used in our network for training with minimal effort, which is phenomenal. The flow for this is pretty simple. The camera stream will be put through the neural network. That will find the tracker inside of the image. Then, depending how far right or left the tracker is in the image, that will just control how hard the robot turns, either left or right. The location of the tracker will be matched to the depth map also from the stereo camera. That will control how fast the robot tries to drive forwards or backwards. Frank is following the tracker on its own, but it definitely needs some tuning.